Hi everyone. Today will be our last lecture, and we have only the last topic to cover. Okay, so that is the disjoint set union, and we are going to use the disjoint set union to show you another minimum spanning tree algorithm. Okay, so what is a disjoint set? For a disjoint set, well, you may remember that in Python we do have a data structure called set. Okay, so in many of the Python courses, it is not really covered. But for long story short, for a set, it is a unordered collection of items. Well, it is unordered, and that is the main difference between a set and an array, for example. So if you're thinking about a Python array, and that is ordered because you can using the index 0 to access the first one, you can use the index 1 to access the second value, right? So they are ordered, and so they are also indexed. Okay, and for a set in Python, it's different. So you can't do index 1, 2, 3 to access the items. It is just a collection of the items, but you don't know how they are stored, and they are definitely not stored in the sequence you want them to. Okay, and then for this course, we are discussing a disjoint set as a abstract data structure. We are not talking about how they can be implemented for now. We are only discussing what are the behaviors that a disjoint set has to support. And there are three things. So the first one is a make set. We can make set of some value we can make set of some value and put those values as the initial values in the set. And then if we have two sets, Si and Sj, and then we can just combine them together, and that is called a union. And the last thing is, if we want to find a find set using a value, and then we just do a lookup, and then we have to return a identifier of a set. So let me go back and show my drawing board. Say if I have the value s, okay, and then I want to do a make set. I want to do a make set s, and then it will give me s as a set. I'm using curly braces showing that that is a set. So the curly braces is also used in Python when we are coding sets. Okay, so that's the first one, to make a set, and then we just specify the initial value or the initial item, and then we are just gonna make a set for such a value. And then how about union? So if I want to union s and t, okay, so I want to do a union with s and t, and then it will give me a combined set of s and t. Okay, and the last one, how do we do a find set? So I'm going to use those three sets as an example. So if I want to do a find set with the parameter a, for example, say I am looking for the item a, and then I want to know which set the item A belongs to. And then of course we see, okay, this is the set where we can find the item A. And the next question is, how do we represent this set? Well, one of the thing is, how about I just give it a name? So if I say this is the set 1, and then find set A will give me the name of the set, which is the set 1. Or if you want to do something else, so I want to say this set, I'm going to name that set red. So I'm just using a color to name the set, and then the find set will give me the red. So in this case, we are just discussing a abstract data type. We are not talking about the real implementation. So, well, we can do whatever we want. So, for example, we can give it a name, and we call that set 1, set 2, and set 3, no problem. Or we can use colors. For example, this is a red set, this is a green set, this is a yellow set, no problem at all. Okay, so we are just trying to discuss how those behaviors of a set can work. Okay, so there are only three things of a set. We need to do a make set, and we need to do unions, and we need to do find set. And the find set is a tricky one. Well, because it's similar that we are doing a lookup, but we are going to return which set this item belongs to. Okay, so that is a quick this is a quick overview of the concept of a disjoint set. So we are not talking about the real implementations. We are going to do that later in this course, and we are going to just use the disjoint set as the basis to discuss another minimum spanning tree algorithm. Okay, that is the Kruskal's algorithm. And at the very beginning, we just set the A to be a empty set. So this phi means a empty set. And then for each of the vertex, and I make a set for them. So for each single of the vertex, I make a set. Okay, so if we have V vertex, and then I'm gonna make a total of V set. Okay, and then we want to do a sorting for each of the edges. We want to sort them, and we want to sort them based on the weight. And the next part, for each of the edge from U to V, and then I'm going to visit all the edges in the sorted order, and then I want to do a find set of the U, find set of the V, and if I find that the U and V, they belong to two different sets, and then I'm going to just union the A with the edge U and V, and then update that to the A. So what it does is I'm taking the UV to the set A, and then I also union the vertex of the U and the vertex V. Okay, so eventually I'm returning the A, and A will be a set of all the edges. And then those edges, if we just put them together, and then we will have a minimum spanning tree. So well, let's take a look on this example. At the very beginning, well, we start from this graph, and then I want to make each vertex a set, right? So we are going to have a bunch of different sets, and then how do I show you they are different sets? And then I decided that I want to use different colors. So excuse me, let me drink some water. Okay, so well, the first step, I just color all the nodes with a different color, because showing they are all different sets. Okay, and the next part, I want to sort all the edges from the low to high. Okay, so after sorting all the edges, and then in the iteration, I'm gonna try to visit all the edges from low to high. So the lowest will be the 1. So I'm putting a question mark here saying I'm visiting the edge 1 for now. And then what do? I need to check whether the U and V, which are the two nodes here, it connects, and whether those two nodes belong to the same set. And of course, they do not belong to the same set. We have a blue set and a red set, right? So in this case, since they do not belong to the same set, and then I'm gonna add the edge UV to the A. Okay, and the next one, I'm gonna union to U and V. So now I'm gonna union those two nodes together into one set. So I'm using the red color to highlight this edge, because this edge will become part of the minimum spanning tree. And I'm also gonna color those two nodes with the same color blue, saying now, since they are already unioned, they belong to the same set. Okay, so well, this is the first step. And the next one, I want to visit the second smallest weight, and then that is 2. So I'm visiting this one. Well, I'm going to check whether those two nodes belong to the same set, and the answer is no. So I'm going to do the same thing. I'm going to add this edge to the A, and then I'm going to union those two nodes. So those two nodes are both in yellow color. And what's the next edge? And the next edge is this 5. And if I'm going to check whether those nodes belong to the same set, the answer is no. So I'm going to do the same thing. Those two, well, I'm going to color that into blue color again, and then 5 will be taken to the minimum spanning tree. And what's the next one? The next one is 8. And then for the 8, well, those two nodes, they belong to different sets. So I'm going to do a union, and then this 8 will be part of the minimum spanning tree. And then the next value will be 9, and this will be different. Okay, so if you see those two nodes, they are already in the same set. So do I bother to do the remaining part? No, because this if condition is a false. So I'm going to just leave the 9 here, and then I'm not going to take this edge into my minimum spanning tree. So if I ask you, what will happen if I do take this edge to the minimum spanning tree? So if I really take this edge, this is not a tree anymore because I have created a loop, right? So in this case, I definitely don't want to take this 9 into my MST. Okay, so let's continue. And the next value is 13. So 13, and then this green will be union to the blue set. So, well, 13 will be taken to the A as well. And what's the next one? 14. So for the 14, and then we are going to combine the blue set and the yellow set. Okay, so now those two sets are going to be combined together, and they're all blue right now. Okay, so if you are eyeballing from this point of view, and it seems that our MST has already finished, right? But we still have to continue, and the next value will be 17. And for 17, we don't want to take 17 because those two nodes, they are already in the same set. And then the 19, the same thing. We don't want to take the 19. Those two nodes, they are already in the same set. And then 21, the same thing, and then 25, the same thing. Okay, so far we have visited all the edges, and then based on our algorithm, we have taken some of the edges into our minimum spanning tree, which is the A, and then we have already colored all the nodes into the same color, which is blue in this case. So that is the Kruskal algorithm. And if you stop here, what you can see is we are taking part of the edges, and we definitely have a minimum spanning tree. And the trick here is we don't have any circle right now, right? So we don't have any circle. So for all the edges which may cause or which may introduce circles. So for example, like this 21. If we take this 21, and then we do have a circle, but we won't take that. Why? Because when we check this 21, oops. So when we check this 21, the two nodes are already in the same set. So we don't have to take the 21 into the A. So this algorithm can definitely prevent that we have any circle in our MST. Okay, so I'm going to pause our video here, and in the next video we are going to move on and try to analyze this Kruskal algorithm. Okay, so I will see you in the next video.